We had this on your last test. This says, in exercises 69 through 72, the cost C of X of producing X units of a particular commodity is given. In each case, find the marginal cost C prime of X. B, find the level of production X for which the average cost C of X over X is minimized. So that was your last test problem. Now we're doing the same thing with a different function. So part A says find the marginal cost. Marginal cost is C prime. So it's just the first derivative. Easy peasy, right? So C of X equals 100 e to the 0.01x. So C prime of X is 100 times, what's the derivative of e to the 0.01x? E 0.01x times 0.01. So that's a times 0.01. And then essentially, if you wanted to simplify it, it's just e to the 0.01x, because 0.01 times 100 is just 1. So that's the answer to part A. Woohoo!
Wait, so you don't think the derivative of 100?
What's the derivative of 100?
0.
0. Mm-hmm.
Okay.
That's why you just take the constant and you bring it along for the ride. B, determine the level of production for which the average cost A of X equals C of X over X is minimized. So I want to minimize A of X, which is C of X over X, which is e to the 0.01x over X. Or we also know this is to being x to the minus 1 e to the 0.01x. Or you could use quotient rule on it if you wanted to.
Would the 100 still be there?
Oh, yes. Thank you. So we want A prime. Now A prime is 100. And the derivative of x to the minus 1 is minus 1x to the minus 2. By the way, this is what problem probably where quotient rule might have been better. E to the 0.01x plus 100 x to the minus 1. Now the derivative of e to the 0.01x is e to the 0.01x times 0.01. So this is minus 100 x to the minus 2 e to the 0.01x, and okay, we're still at a plus 100 x to the minus 1. Well, 100, well, this is just that guy, because 0.01 times 100 is just 1. So it's just x to the minus 1 e to the 0.01x. This is not simplified. I have a greatest common factor of e to the 0.01x and what? No. Negative 2. It's always the smallest power. That gives me 100. I'm taking the x to the minus 2 and this guy plus, from the x to the minus 1, I'm removing a minus 2, and I'm taking that guy. equals x to the minus 2 e to the 0.01x times minus 100 plus what? That's plus. Minus 1 plus 2 is 1x. Now, since we are going to minimize, I need to find the critical values. So I need to set this equal to 0. And x to the minus 2 is 1 over x squared. Well, in this case, x can't be 0, right? But from the very beginning, 0 was a what? What's 0? From the very beginning. It's a vertical asymptote, right? So is he going to play a role in the maximuming of things? Well, what's the domain of this guy? 0 to infinity, right? Because we're talking about cost, hopefully. And so, and this tells me that x is what? Now, the only question that I would have is it a min? We're hoping it is, right? How would I find out whether or not it were a min? Yeah. I can put this on a number line. Right. And this guy starts at 0, not including 0, because 0 is not in the domain of the original function. And then I can look to see if it's a minimum, it should be decreasing followed by increasing. Or you could take the second derivative, but do we want to take the second derivative and use the second derivative test on it? No. Stupid I'm not, right? But here's the thing that's beautiful about this problem. You don't realize this. Any x value I put in for here, is that going to always be positive or negative? Positive. So this guy is always positive no matter what. You give me an x value, it's always positive, right? Any x value you give me, what do I know about this one? It's going to be positive. It lives or dies by 100 minus x. Does it not? So now I just pull a number, 99. Right? 100 plus 99, positive or negative? Negative. This is multiplicity 1, change positive. And I got decreasing followed by increasing. This is a min. So the level of production to minimize average cost is 100 units. See, the beauty of some of this is that you can save yourself a lot of work. If you can basically say, like I did here, I put in any x value that's negative, that's positive always. E to the 0.01x is always positive. It lives or dies by 100 minus x. Yeah.
Could that also just like if I didn't clue into that during the test, could I just like enter that equation into my calculator and graph it and then do the calc for x equals 99, x equals 101, and it'll pop out?
Sure. You mean if you put the derivative in?
Yeah.
Because you don't want to put the function and you want to put the derivative in.
Right.
Because otherwise you won't get the minus plus what you'll get the y values on the original function, which does not tell you max min.
Right, graph the
Yeah.
derivative.
Yeah,
Cool.
that worked too. All kinds of ways to come at this.